Music, photographs, documents. What used to take up shelf space in our homes and offices can now be stored on a tiny memory card or flash drive. You can save your files on it, take them out of the device, and transport them anywhere, as well as delete data you no longer need. A memory card fits into a slot in your digital device. A flash drive plugs into a USB port. The key component of both formats, a memory chip, produced in a factory that's 1,000 times cleaner than a hospital operating room. It all begins with the wafer, a thin disk of pure silicon, a non-metallic natural element that conducts electricity. An automated container system moves the wafer through more than 800 operations. At each stop, the wafer receives one of several layers of non-conductive materials such as silicon dioxide and conductive materials such as copper. The machines coat the layer with light-sensitive fluid, then apply UV light through a glass stencil of the complex pattern of electrical circuitry. The exposed areas of fluid chemically react, locking the material directly underneath into the circuitry pattern. Chemical baths then remove the surrounding fluid and material, leaving only the layer of circuitry. Electrical pathways 2,000 times narrower than a human hair. A robot tests the circuitry for every memory chip on the wafer. A single wafer, measuring 12 inches in diameter, yields hundreds of memory chips. The goal is to make those chips as small as possible. In this industry, it's all about maximum memory in minimal space. That's why this operation thins the chips by grinding away 2/3 of the silicon from the back side of the wafer. And one last step before cutting the wafer into individual memory chips. This machine applies tape to hold the separated chips together. A computer-guided saw slices the chips apart. Cutting silicon is like cutting glass. It requires a diamond-edged blade. In the next step, a robotic arm, following the wafer map generated earlier, picks up the chips which pass testing and attaches each one to a fiberglass lead frame. The term lead refers to the frame's pins, which connect the chip to the digital device. Another robot wires the chip to the lead frame with gold thread that's about the width of a human hair. Gold is very conductive, so now the pathway is complete. Electricity will travel from the chip circuitry through the gold thread to the pins to the device. After a machine seals the chip in plastic, workers gently snap them apart and insert them in memory card housings. The plastic and metal housing is for a memory card format known as compact flash. A small automated press locks the two halves of the housing together. The next station labels the front of the housing. Every single memory card undergoes testing for both function and speed. A laser machine etches product information into the back of the housing. These are another format called Secure Digital or SD. They're assembled and labeled just like the compact flash cards. When the finished memory cards come off the assembly line, workers conduct a final visual inspection. On the flash drive assembly line, much the same process. A robot puts 20 lead frames on 20 circuit boards. Then a worker positions 20 USB connectors, which a soldering machine bonds to the circuit boards. The final step, electronic testing, to make sure the USB connection is working and via the circuit board, talking to the chip. The flash drives are now ready to go into individual housings. This model has a two-part plastic housing, which pivots in and out of a plastic case that can conveniently be attached to a keychain or a lanyard for easy portability. Flash drive or memory card. Storing your digital effects is just a click away. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/how it's made.